Huh, weird.
Well, there's nothing wrong with that.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Jenny List.
This is episode 331, Clever Machine Tools Storing Data in Birds and the Ultimate Cyberdeck. This week in Hackaday news, the 1 Hertz challenge rolls on. If you haven't seen, we've been posting up, probably an entry per day for the last week. It's one of those where just the sheer craziness of the goal has brought out the sheer craziness of our readers. So definitely give those a look if you haven't yet.
I'm certainly enjoying reading through them as an editor.
It's fun what it brings out of the woodwork. We can't play favorites. We won't talk about them now. We're not going to play favorites.
Every one of them is awesome.
Yeah, right? If you have something / anything that does something once a second, you can enter it in the 1 Hertz challenge, which is running until August 19th at 9 a.m. Pacific time. So you've got a little under 3 weeks to get it done.
Plenty of time.
Yeah, we were saying that back when it was 6 weeks, but now it's half of that. So, time for procrastination is slowly ending.
1 second per second, in fact.
At a rate of exactly. Yeah, perfect. And with nothing else on our newsy plate, let's head on off to What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
This week is a Guess the Sound week, so I'll play a brand new sound. Jenny gets the first shot at it, and then you, our listeners, get a second shot. If you get it right, you can be in the running next week for a Hackaday podcast t-shirt.
Right, let's give it. It's some kind of data transfer mode, I think.
Not bad.
I'm not certain exactly what. It's not one I'm familiar with from amateur radio, but it sounds like the rising tones are testing the bandwidth of the connection. Then the noise-like sound is the data, and then it finishes up with another set of tones, presumably for some kind of end check to check that it still has the bandwidth.
Ooh.
Or am I grasping at straws?
You are completely off base, but that's a fantastic guess. And I love how well rationalized it is. That was a supremely well thought out guess.
The key is, when you're making something up, sound completely sincere.
And I'm sure there are like test tones like that I'm now I'm writing that down for future What's That Sound, because that's a great idea. I'll tell you what it is just for fun. It's an sonification of.
Oh.
And I think
yes, I suppose. Yeah. That makes absolute sense given the sound, but I would never have guessed that.
Exactly. It's one of those you just had to have seen it. I actually just put this on here because I think it's an awesome video and our listeners should check it on out.
Fantastic.
If you do know what it was, head on over to hackaday.com/podcast. Scroll on down to What's That Sound, enter your best guess and your handle, and we'll see who gets it right. If you don't know what it is, tune in next week and you'll have an awesome video to watch. Well, I'll start off this week with AJC 150's painting in metal with selective electroplating. I saw this and I'm like, well, when life gives you lemons, and in this case, the lemons are the form of one of those 3018 format CNC routers, which really are just basically kind of crappy machines. What do? You make something cool out of it. And in this case, he's making an electroplating robot. As bad a mill as these weak and wobbly aluminum frames make, it makes a fantastic 3-dimensional positioning apparatus. And so that's what he's using it for here. The gimmick is, instead of doing what you normally do when you electroplate, which is to put down a nice, solid, even layer everywhere, he's doing the exact opposite. He 3D prints a funnel that comes down to a kind of 1 or 2 millimeter nozzle and is point electroplating. And it's kind of like dot matrix electroplating on a piece of metal that sits on the base there. So he's got a bowl with the electrolyte in it. He's got the metal he wants to plate in the bowl. And then he's got this funnel apparatus mounted on the head of the former CNC router. He moves it around, and of course, the longer it dwells in a particular spot, the more metal gets deposited there. And so he's putting down nickel and copper and zinc. Take your choice of what metal. And basically, he just puts a metal strip into this funnel and clips on the lead to that. It's really fun. I always say that everyone who does any machine projects should have a good knowledge of G code because it's really fun to get down to the lowest level and mess around with it. And this is one of those cases where because AJC knows G code, he can write his own routines for this. And I mean, you don't need to write your own G code if you're just slicing 3D prints, right? But if you want to do something wacky, it's totally useful to know how to drive one of these machines. So he writes a quick algorithm, takes a photo in and exposes the different dots. And then he also wrote another one. All these are in his GitHub, of course, that does the gamma correction for you. So depending on everything, how far away the nozzle is, what metals you're plating, how strong your electrolyte solution is, basically everything possible, you can imagine that it'll deposit more metal per second. And to get a nice looking exposure, you have to be able to control this. And so he has a gamma correction script that basically just goes across a line more and more and more and more slowly. And so you can pull it out, look at it, pick the one that looks like it gives you the best contrast. It's just a really cool build. It's something that I'd never thought of doing before. You just put a copper sheet in the bottom and you plate nickel on it and you get art out. That's a really cool idea and a great use of one of these machines that's kind of in its intended role, kind of a cheesy, not 100% awesome machine tool.
It's interesting to me that it relies on what is pretty obvious thinking about it, but I'd never thought about it before, that the piece of metal closest to the other electrode is the bit that gets the most plating. So there's no mask involved here. It's merely relying on most of the metal going closest to the probe, which is probably obvious if you're an electrochemist, but I'm not an electrochemist, and I would have expected the whole thing to have got a little plated. But obviously the ions are only travelling the shortest distance, which I certainly was a bit of an eye-opener for me. I hadn't realised that was how that would work.
It's actually really cool. If you look at some of his prints super up close, you can see the dots, but they're not always straight down and they're not always symmetric either. It's a really neat problem, and AJC wants to push it in some new directions. He wants to work on, maybe having a couple different heads or multiple nozzles at once, and working on a problem he says he has with spillover. I guess that's kind of what you were thinking, Jenny, where, it doesn't go straight down. It's not like, an ink. Well, I guess with inkjets, I was going to say it's not like an inkjet, but of course with inkjets, they kind of spread out into the paper and bleed out a little bit too. So maybe it is just like an inkjet. What do I know?
Either way, it's an amazing project.
Yeah, and it's just really cool to see what you can do with a little bit of Python code and a machine that's able to move in 3 directions. One of which you probably have kicking around if you have an old, crappy, unused 3D printer. So you could do
Plenty
this.
of those in the world now.
Yeah.
Next up is from Sector 07, and it's a Cyberdeck. Now, Cyberdecks, sort of futuristic cyberpunk computers, are something that we've featured a lot over the years, and we've brought you some very impressive builds, from the very sort of look like they're made out of waste materials to the very professional variety. There are many different ways to do a Cyberdeck. I can confidently say that this one is probably one of the nicest ones I have ever seen. Has a full-size mechanical keyboard, it has a Raspberry Pi running the show, and it has 2, I think they're 8-inch touchscreens. But it's the way that it's designed, it's the attention to detail that has gone into the mechanical design of the thing that sets this one apart. The touchscreens are mounted on a bracket which hinges up from the keyboard, almost laptop style, and they're side by side, and they can be rotated from portrait to landscape independently. There are a set of buttons and a scroll wheel that can be programmed. There's GPIO expansion. I think that's most of the features. But it's the design of the hinges and particularly the ball bearing rotating joints for the monitors, which make it way apart from virtually all the other Cyberdecks. This could be a commercial product. The way that the hinges work seamlessly. There's nothing janky in this build. And little attention to detail things like the plugs and sockets for the Raspberry Pi. It's actually designed it such that the Raspberry Pi board can be taken out of the machine, and all the cables that plug in are little 3D printed carriers. So to plug in or unplug, he simply just has to pull out the carrier with a little tab at the side of the machine, and the Raspberry Pi is disconnected. It's a machine that I could definitely imagine myself taking into the futuristic cyber cityscape. But more to the point, it's one I could actually imagine myself using day to day to write Hackaday, which, given the number of Cyberdecks that we've seen over the years, it's quite impressive that this is the first one that's really struck me like that.
Yeah, this is by far, I guess it's the prettiest I've seen in a long time. It's also kind of cheating. Like, a lot of the Cyberdecks are meant to be portable, fold up, more or less, somewhere between slab and suitcase sized. And this one looks like it's meant to sit there forever on your desk, which is...
I think it is designed to fold up and carry around.
Yeah, I guess you can. I mean, the screens and the whole screen assembly is absolutely awesome. And
it's next level.
Like you said, the one that pivots up is super, because you always want a portrait monitor and a landscape monitor, right? Right.
Absolutely.
And it's on, and the fact that it's on ball bearings, and this is.
It has built-in pins to limit the rotation, and
I think it would never leave my desk. I think I would just leave it there and use it the whole time, because it looks far too sleek and far too functional to carry it out in the world.
I would want to take this to hacker camps with me. I'd love to have it set up in our hacker camp village and just be banging away doing Hackaday on a sort of futuristic Cyberdeck rather than a Lenovo ThinkPad.
Right.
That shows how old I am. I said IBM ThinkPad without thinking.
Here's the moment of truth. Does it have a battery in it? I'm clicking through and I can't find it. I think this is a desktop Cyberdeck.
Well, that in itself is not a bad thing, in that
I'm not
quite a lot of
complaining.
Cyberdecks use USB-C battery packs. There's nothing wrong. There's no shame in using a USB-C battery pack, I'd say.
Oh, fair enough. I buy it. I don't think it needs to be portable to be a Cyberdeck. Does it? Audience, argue among yourselves.
I really ought to have a go at this Cyberdeck lark myself. I've made enough cameras and audio and random other things. I should make a Cyberdeck for a Hackaday writer.
Yeah, absolutely. Dave Darko had one that he built into a little miniature box, and that's always been the form factor I want, with a screen on the front and just kind of a luggable box case with like everything inside it, all of the tools. Mine doesn't need to be as fancy as these ones. It just needs to be a box full of tricks.
Well, I actually have the original for that. I have the same compact luggable that one of the characters in Hackers used, even though the one in the movie had a Mac grafted into it. And it still works. It's a 486, which means that
Oof.
functionally it's useless today, and it's too good to whip all the parts out and put something modern in.
Yep.
But at the same time, I wish I could do something with it. So I've got this awesome luggable compact 486 with a 640 by 480 LCD screen that's nice to look at, but I can't use. Also, it's got a French AZERTY keyboard for some reason.
That's awesome. Well, next up for me really blurs the lines between product and hacker project. This is the Compass CNC router. I'm realizing now that I'm on a total machine tool kick today. Listeners will excuse me. Human in the loop, Compass CNC redefines workspace limits. And this is, it's a handheld portable router with a flat base, which is a heck of a lot like the Shaper Origin, in that it uses some amount of computer vision and machine smarts to move the router head around. So you kind of broadly steer it, and it does the fine detail cutting and make sure your lines are cut straight. I've always loved this design. I remember when the Shaper was a hacker project, and I thought it was absolutely brilliant, because it pulls the strengths out of both the human, who's good at moving things around arbitrarily, and the machine, which is good at doing the fine precision stuff. The Shaper, if you've seen one, it uses a camera and you have to put fiducial tape down, and it's a little bit hard to use. It also has these incredible wild cam mechanisms that take care of moving the cutting head around. This one instead takes a much more kind of 3D printer-esque approach and is basically made up of 3D printed parts and 3D printer parts. The cool thing about the Compass is that it's completely open source and it's also evolving. We covered it a few years ago, back when it was only a 2 degree of freedom machine. This version adds in Z-axis travel as well, so it can lift the head up and move it around while you're doing it. The guy who designs the Compass CNC, I can't find his name anywhere, said he completely redid the motion algorithms on this one too, because the last one was kind of you're steering it around and the control algorithm is correcting for your movements. Now that it can go up and down, it's trying to tell you where to go and you're doing the kind of bulk movement. And it's got a little round screen where it shows you where it wants the cutting head to go and you can move it around. In place of the fiducials that the Shaper Origin uses, this one actually has 4 high-resolution mouse sensors on the bottom. I think the coolest part for a lot of people here is that it has a flat plate on the bottom, which makes the dust extraction super, super efficient. Like it can kind of guarantee that it sucks all the dust up, which is pretty cool. And of course, I guess that it's an entirely open source project. It still isn't going to be super cheap, and the company's, I guess it's a one-man hacker company, but his website sells a kit to make this, which has like, the rails and the stepper motors and the flat milled out aluminum base and all the stuff you need except for the 3D printed parts and the handheld palm router itself. And that still runs you about $600. So it's not impossibly cheap, but it's a lot cheaper than the Shaper Origin, and it's an open source design. So you're going to be able to upgrade this thing as he puts out new and improved designs. And I think that's actually maybe the coolest part, is that it looks like it works really well right now. But if it works better in the future, you can just turn your current one into the new one because you built it yourself in the first place. That's one of the best things about 3D printers is you can always hack on them and make them better. And this is that for a cutting router. And I love that.
I fully agree. It's the Prusa 3D printer model that you buy a Prusa and you'll always be able to upgrade it to a slightly later Prusa. There's an asterisk there, of course. Prusa have taken some of their products out of open source now, but it's a nice idea nevertheless.
For this kind of market, for the hobbyist maker hacker market, it makes a lot of sense because, we are the kind of people who, when the state of the art gets a little bit better, we're going to want to keep up with it. And we're totally not afraid of keeping up with it ourselves. And I think there's going to be a huge overlap here of, people who want to do a little bit of accurate light wood cutting with the people who run a 3D printer. It's the wood cutting 3D printer.
Now we have a really, really interesting piece of work that really comes into the science domain. It's from Ben Jordan. What he has done is he has managed to store an image in a bird. Now, if that sounds a little odd, what he's done is he has played a spectrogram of a little sketch of a bird, actually, to a pet starling who is noted as very, very good at mimicking the sounds that the bird hears. And the starling has learned the sound and has been able to reproduce it such that you can retrieve the image of the bird in the spectrogram of what the starling is saying. That's actually storing quite a lot of information in a bird, but it's a demonstration of the bird's, quite frankly, amazing vocal capabilities. And it's also very interesting. He does quite a lot of going into sort of microphones and ultrasonic microphones and stuff like that. It's a fascinating and entertaining thing to see. We made a bird say an image, but there's also many other questions that you can apply to this. If you consider a sound as data, how much data can a human do? I don't think a human would be able to repeat a spectrogram in the same way. Maybe we should try sometime. The first person to belch a Hackaday logo, I will buy them a pint at EMF next year. You'll cut that out, right?
We'll see.
If you think about it, when we memorize a song or a tune or a piece of poetry, we're memorizing data. Now, with a song, we're doing words, whatever. With music, we are actually doing a coded data. I mean, we don't think of music as data, it's a pretty sound, but in fact, it's serial data. And if you look at it in the frequency domain, it's tonal data. And it wouldn't be too difficult to encode numerical data as either a serial data stream, 2 tones, sort of a bit like an old-fashioned modem, or a set of chords or sequential tones, like some of the later modems, the famous modem sound from before we all connected to the internet permanently. It would be a fascinating experiment to see how much data you could teach a human. I suspect the amount that a human could remember would be a lot less than the amount that a human could say. So, for instance, if you had the notes in front of you and you could read them, you could probably reproduce the data as notes. But whether you could remember that data would be an entirely different matter. I suspect that a lot of remembering tunes isn't so much remembering a sequence of data, but remembering little bits of tune and how often they are repeated. And also the fact we probably have some capability for remembering tunes rather than just random notes. I would love to see somebody try that kind of thing, because I'm really curious to know how much data can a human store if a bird can store a picture.
I think the birds have us on this one.
Probably.
They can make a whole bunch of different pitches simultaneously in a way that we just do not have practice doing. Like there's the Tibetan monks who do their overtone singing thing.
Yeah.
Can maybe control 2 pitches simultaneously, but birds can do, 2 or 3 easily, and some of them up way so high. It's really, really insane. So I don't know, Jenny. I think to answer your question, the birds got us on this one.
They probably have, but it's still a fascinating topic.
But I like your idea of trying to encode data in pitches. You had me brainstorming, like, I wonder if you could remember pins or something this way, right? Like if you had a good system to remember numeric digits, you could probably learn people's phone numbers or your security pin or something a lot better if you could do that. And I've never heard of anyone do that. All right, wrapping up Elliot's machine tool episode, I've got 2 hacks here that I just wanted to cover briefly. They're so related that I wanted to put them together. They're both about cutting or lasing on round objects, but neither of them actually use a rotary stage. And I thought that was pretty wild. First comes from the Fabrication Series YouTube channel. Skateboard wheels add capabilities to plasma cutter. And this one's really clever. He is basically built a little standoff with some skateboard wheels on springs that push a pipe hard down into the table and simultaneously let it roll. And so what this machine is doing is, as it moves its gantry across, it's rolling the pipe along. If you know the diameter of the pipe, say it's rolling in the y-axis, you can then use the x-axis to cut kind of arbitrary end shapes on the end of the pipe. And so that's what he's doing here, is using this on a plasma cutter to make kind of an arbitrary tube notcher. If you imagine you want to put 2 tubes together, it's got that kind of curvy form. And if you want to put 2 tubes together at an angle, the joint's going to be a yet more complicated shape. And being able to do this programmatically, being able to do this in CAD is super awesome. And there are specialized machines that usually have a turning 4th axis that let you make these specialized shapes on the end of tubes. But a tube notcher is not something you use every day unless you're bike manufacturing. And so I think this is just such a clever hack to roll the tube across the ground, making a fake rotation axis out of one of the axes you have by just holding it down with some rolly wheels. Really sweet idea.
The Hackaday write-up makes the point that the skateboard parts bin is actually quite a good one for makers, because generally the parts are built quite tough. And it's something I'd never considered. Sadly, I was one of the kids in the 1970s whose parents wouldn't let them have a skateboard.
Oh,
Split British society in the 70s down the middle. The kids whose parents would let them have a skateboard, the kids who wouldn't. And I was on the wooden side. So I never got to familiarise myself with skateboard parts. This has affected me my entire life.
oh, that is horrible because you're totally right. Little hard shortboard skateboard wheels are superb. The bearings are of course awesome. Like if you need bearings for anything and you can make skateboard bearings fit, they're dead cheap and work everywhere. So, yeah, good point. Second machine tool hack I had is a little bit shorter. This one is engrave a cylinder without a rotary attachment, no problem. This is a laser cut engraving video by Samcraft. He's basically cheating here. If you want to engrave a fancy pattern on the side of a mug or something, that's another one of these cases where you want a rotary fourth axis so that you can spin the thing as the laser passes across. He basically builds a jig that holds the cup in place and then rotates it by hand in between passes. And the bit that makes this work for him here is that he's cut the picture that he wants to engrave around the side of this mug into a bunch of vertical slices. Because the laser's going up and down the long way on the cylinder, it stays in focus. But as it moves off of the curvy end, it loses focus as it goes either to the left or the right. And so you have to be really careful about, taking kind of thin slices and rotating it and thin slices and rotating it. I was a little bit disappointed here. Samcraft's plan is one step too clever. He picked a design that made it easy to cut into vertical slices without any particular overlap. I was wondering how he managed to, turn it just the right amount to get the two different stripes to line up with each other. And he just kind of punts on the problem entirely and avoids it, which...
Yeah, that would be difficult by hand.
Yeah. That said, it looks great. And if you can take this solution, it's a cheap and easy solution. You can turn it with your own hands. You've got your hands. They're paid off already. So, it's not a problem. But... at the same time, I wanted to see like some kind of computer vision solution or some kind of like hyper clever jig there. But no, it's just clever pre-processing. Turns out you can do a lot by being smart up front.
Makes sense. My final hack comes from Stephen Hawes, and it's a solder pasting system using CNC and a syringe on a Lumen PNP. Solder pasting, obviously it's a mixture of powdered solder and flux. You apply it to the pads on your PCB, you drop the components on top and you bung it in the oven and the whole thing is soldered at once. Normally this is done with a stencil. So when you order your PCBs, you'll get a stencil laser cut and you then apply the stencil. In his particular case, he's making his own PCBs from scratch. So he's tried making his own stencils and he's not very impressed with them. And the obvious thing to do is think, can I put the solder on by any other means? Probably most of us have at some point applied solder paste by hand with a syringe. It's very, very fiddly and probably a bit messy. But with a CNC machine, he's actually doing a reasonable job. The mechanics of this they require a bit of engineering thought, and he goes into it in the video to make a dispenser that can dispense the sort of quite thick and viscous solder paste. But the really clever hack here is the whole thing is controlled from a web browser. The web browser runs OpenCV in WebAssembly in the browser to spot the fiducials, so you don't have to line up the board. It will plot the fiducials and line up in whatever sort of angle the board is, and then write the G-code to pilot the applicator to the relevant part and deposit the solder paste. I think most of us could probably make a solder paste syringe to attach to a CNC machine of some variety, but making an in-browser machine vision system to guide it into place for your board is next level, and I was very impressed by this one.
Yeah, Steven's just pulled so much out of his pick and place machine. It's unreal. And I guess we featured this a while back when he was just starting his solder paste experiment. Back then it was, worrying about the viscosity of things and how to get the dosing right. And of course, he's worked through all those problems, and now it's like how to get the placement right. I've never really was so super into the browsers should have a serial port and browsers should be able to run arbitrary code.
I'm with you there, but it's still impressive that he has.
I'm kind of a little old school and I love to see the web just be the web. But as long as you're going to admit that the browser's the kind of new de facto operating system layer, why the hell wouldn't you recode OpenCV to run on it and have it drive your machine? No, it's absolutely bonkers and really clever.
With respect to browsers running code for serial or USB, it's an annoyance of mine that Firefox doesn't support it usually, so you have to fire up something with the Chrome engine. And then invariably on a Linux machine, you for some reason don't have permissions for the serial port, so you have to fiddle around with group permissions for a while, and I just want it to work.
That said, it's absolutely the most handy thing when you're able to just plug a USB-C into your phone, running the app, and then it can do your serial control for you. So
That is true.
we do live in a much better world because of it.
It's nice to know something's good in the future.
Exactly. Okay, my first quick hack is a demo from JLC PCB. Transparent PCBs triggers 90s nostalgia. There's not much to say here except they've got a transparent PCB substrate and it looks pretty rad. The demo here is an Arduino and it will definitely make you go aw. Everybody chimes into comments about, where's their ground plane and etc. And I think that's probably true. You probably are missing out on a lot to make your PCBs look good when printed on transparent substrate. But, when you need it, and now you know where to get it. Wenzel Labs made the craziest Eurorack module listening to Ethernet via Eurorack. This one plays Ethernet traffic. It's a hub basically, and in the middle, it amplifies it and goes off to a speaker. His demo is phenomenal though. He's sending out ping with the different delays to make rhythm tracks. He then, writes this all into a bash script called dobeat.shell. He then uses TCP dump to record the network traffic that's being played there, and so he can play it back later. This one ends with him essentially generating bitmaps that have repetitive patterns, sending them over X to an X term so that they generate network traffic that sounds kind of musical. Oh yeah, and then the last trick is he takes some samples, up converts them to 25 megasamples a second for bit depth and plays them so he can actually play wave files at Ethernet speed. I mean, the files are huge, but they actually play when you just listen to the bit stream. Absolutely hilarious. Real quick then, read QR codes on the cheap is a cool write-up by James Bowman of the Tiny Code Reader, which is an I2C QR code reader that sells for only $7. And it is basically an Arducam sensor and an RP2040. And to quote James, the rest is software. Made by a company called Useful Sensors, which also makes a person detector. Also, essentially the same thing, just different software in there. Makes you think for $7, a camera and an RP2040 in a little case like that would be fun to hack on. And last up, 1 Hertz challenge, a clock sans silicon. Charles has set himself the challenge of making a digital clock with no silicon in it. So that means it's all vacuum tubes. And he is using some semiconductors, but he has managed to find all germanium parts. But as Lewin cheekily points out, of course, you can't have vacuum tubes without glass. And what is glass? Silicon.
First up, I spent middle of the 1990s working in the computer games industry for a game developer based in the UK, and some of the games were PC games, but at the time the big console to have was the PlayStation. The original PlayStation, of course, later known as the PS1. It was quite a complex machine for its day. It had I think a 33 megahertz MIPS processor and 4 megs of memory, which in the mid-1990s wasn't too bad for a PC. It was in the early 90s, 4 megs of memory had been a lot of memory for a PC. Laurentio B has come up with a replacement motherboard for the PlayStation 1. It's now old enough to need a replacement motherboard. Now, obviously, as retro computing hardware gets older, it can get less reliable. That can mean printed circuit boards fail, it can mean capacitors leak, it can mean corrosion, all sorts of things. So it's quite common now with the likes of the Commodore 64 or some Amigas or other similar computers to have replacement PCBs. And the idea is you transplant the chips from your existing PCB and maybe some new chips if they're available, and you get a machine that is much more reliable. And now the PS1 has moved into that lane. It surprised me in a way because, of course, it's quite a complex board. There's a lot of high density electronics in there, but it's perfectly doable. I certainly used to know that board particularly well because there's a nice little sideline in the mid-90s installing mod chips for people who couldn't do surface mount soldering. The board itself actually brings back a few things that were missing on some revisions. It has the parallel port, which, did anybody ever use the parallel port for anything? Which is interesting. It would be interesting also to notice whether, I didn't actually see this, whether he's put in the space for a mod chip to just go on the board so you don't have to wire it in. But then again, if you want the authentic 90s feeling, then lots of little bits of kind of wire snaking around the place is the genuine 90s experience. Next up, the Eccentric Workshop has a cable modem, a new cable modem. And in the way of cable modems, it's designed as a home appliance and it's designed to look futuristic. So it has a swoopy round plastic case, which is great, except they have all their network stuff in a really nice 19-inch rack. And they wanted to put the cable modem in the rack too. Now, it would be straightforward, I guess, to buy a network rack shelf and just shove the modem on the shelf. But no, what they did was they took the case apart, took out the PCB, mounted it in a 3D printed carrier with a custom 3D printed light guide for its LEDs, cut a beautiful 1U front panel with the manufacturer's logo, the part number and everything, and made a 19-inch rack case for this cable modem. So it looks for all the world as though it was shipped as a 19-inch rack unit. And it's a beautiful piece of metalwork and it's a fairly straightforward hack. I just liked the idea of taking a home cable modem and turning it into a professional piece of kit by putting it in a very nicely made 19-inch rack. Finally, Random Alley Cat has made a handheld Raspberry Pi based terminal. And we've seen quite a lot of these in the past. They seem to be very much a thing at the moment. This one is particularly nice, though, because of the way that she has designed it. If you've ever made something like this, there's always a problem getting everything into the case because you've got lots of little boards and modules, you've got minimal space, and you've got to squeeze all the wires in, and it can be a mess. And what she's done is, what with hindsight is obvious, but those of us who've tried making these things don't always think of it. She's made a chassis. The outer shell is sort of a clamshell that goes over the chassis. So the chassis has all the places and lots of access from both sides to get the modules. I think it's got a Raspberry Pi 02W and a Pimeroni hyperpixel screen. There's a some kind of UPS board for the Pi with a battery and a few other bits and pieces. But it's all very carefully laid out on this chassis with the right wires in the right place. And then the clamshell just snaps over the top of it and you have a beautiful handheld Pi. But even then it's not finished. The Pi has connectors on the bottom, and of course, being a Raspberry Pi, the connectors are always in the most inconvenient places. Sorry guys in Cambridge, but I understand it's the way that you made your boards, but sometimes putting a Pi in a case can be annoying because the connector's on the wrong side. What she's done is she's made very nice recessed places underneath, so you can slide the cable in and it mates up with the Raspberry Pi. It turns a connector in an annoying place into a feature that looks as though it was designed that way. I particularly like that. This is, just like I said about the Cyberdeck earlier, this is a handheld Cyberdeck I would like to take with me into the post-apocalyptic future. And that's my quick hacks for the week.
Quick hacks.
That brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I picked Dan Maloney's Powerline Patrol's The Grid's Eye in the Sky. And if you had a large power line network that happened to power an entire nation, you might want to make sure that your power lines are still working correctly. And that means all sorts of things, like the trees aren't growing into them, their insulation isn't deteriorating, and they're not arcing over, et cetera, et cetera. And Dan was looking into this because he saw a bunch of helicopters flying around outside by some power lines and was like, hey, wait a minute. What's going on here? Why are people even still doing this in the most dangerous possible way? That is, with human beings close to these ultra high voltage power lines in 2025. Why is this not done with drones? Why is this not done, some other way? And so he went to look into it. And that's where this article comes from. But basically, the conclusion is what you would be afraid it would be, and that is that people in a helicopter can just do a much better job at figuring out what the state of the power lines are. They have infrared cameras so they can tell if a wire is getting hot. They have spark cameras so they can tell if it's emitting UV because, like coronal discharge will spit off UV. And so they've got some really cool cameras that help them find out where they're arcing over. All sorts of things, but I guess humans have depth perception. It's better for us to be able to see if a particular site's getting overgrown by trees or whatever. There's a whole bunch of other factors. How close is too close for trees to get to super high voltage power lines? There's always going to be a little bit of loss depending on what's growing up underneath them. But at some point, they have to get in there with a crew of people and cut them down. Long story short, it's a weird job that I'm kind of surprised still exists, but it does because even given how good computer vision is and how awesome lithium-ion batteries are that they can put quads up in the air for a long time, it's still just easier to do it with people and a very steady pilot in dangerous proximity to high voltage power lines.
Certainly in a country the size of the United States, you can see the scale of the problem. Here in my rainy corner of Western Europe, it's actually quite easy to get to most of the power lines, and most of them in America terms are not very long. I can see when you are crossing an entire American state, which can have a wilderness bigger than a British county, this becomes a significant problem.
My sister was out visiting and was asking me how big Germany is compared to American states. And I'm like, oh, I don't know. But the answer is terrifying. Germany is the size of half of Texas.
Yeah, I suppose that figures.
Germany, an entire country with an entire culture, its own freaking language, is half the size of Texas.
And Germany is proper big too.
And compared to Jenny, who's in the Netherlands... Yeah.
Yes.
Yeah, or England. Yeah.
I went to BornHack last week, and you think you're nearly there when you get to Hamburg, and then you've got to drive all the length of Schleswig-Holstein, which is really big. And when you look at the map of Germany, that's only the little chunk at the top. If I was driving from Flensburg to Munich, where Elliot is, I would be driving probably all day and all night.
And you whine about it, but it's still like driving from Dallas to Lubbock. So this is why people are up there in helicopters looking at power lines.
Now, for my final piece, I want to talk about something close to home to me in the United Kingdom. The Online Safety Act has just come into force. Now, this has been something that's been rumbling along in the background in privacy circles for quite a while. What it is it's very much a bit of a think of the children kind of piece of law. The idea is that it's to protect kids from either online abuse or exposure to dodgy things online. And it also brings in some offences to do with cyber stalking and stuff like that. But what they've actually done is impose a stringent age verification requirement on websites serving content to people in the UK. Now, this obviously isn't every website. I don't think, for instance, that Hackaday has to do it, but a huge number of websites are caught up in it. And a lot of smaller websites are turning around and saying, we just simply can't afford to do this. A lot of larger websites, for instance, Wikipedia, are looking at it and saying, is it worth our serving to the UK? There's certainly been stories of people at Wikipedia mulling whether they should block the UK at an internet level. It's something that's very much unresolved, but it has thrown an absolute firebomb into the way that Brits use the internet. The upshot of it is that VPN usage from the UK has gone up enormously as people seek to get past it. And the ingenuity of kids has gone up. This is how we're going to train the next generation of cybersecurity specialists. Because, of course, when you present kids with some blocks or something, they'll find a way around it. And apparently the favourite is AI-generated fake IDs, just like Americans have been using for years to get alcohol. There's even somebody has done a brilliant parody site where you can stick in your British postcode and it will dig up your member of parliament and make a fake ID with their face on it, which I'm sure that a lot of people are going to take great delight in using Keir Starmer's ID, because of course all the ID verification is done by AIs. So if it just looks like a British driver's license, they'll probably get through. It's a classic example of a poorly thought out law. I mean, every country has its laws that were brought in haste, but usually because of some moral panic in a newspaper, and then repented over at leisure because they mess everything up for everybody. And this is an example of one. There is a petition on the British Parliamentary Petitions website asking for its repeal, or at least its reform. If you're a Brit living in the UK or abroad, you can sign it. And it's something maybe you should give some consideration to. But meanwhile, it's a chilling illustration of how the internet as we know it can be broken so easily and is so fragile that a piece of legislation, that even one that isn't designed to break it, can break it. Hackaday doesn't normally cover politics, but this is one of those odd moments where politics and technology intersect in a space that we and our readers are interested in. So I think it's something that we need to be talking about, because it could be that the British government will see the error of their ways and reform it, or it could be that other governments will think, hey, that looks like a good idea, we'll mess up our internet too. So it's something we need to be watching out for.
It does make you wonder how they classify harmful content, and that could be kind of ugly. There's all the privacy questions. I mean, the goal sounds actually fairly laudable, and I think it is reasonable
Yes, it does.
to restrict access of underage people to a whole bunch of things. And but I fear it gets too quickly into personal opinion. Like, I would say that kids shouldn't be on TikTok. That's going to be an unpopular hot take among 14-year-olds around the world. Like, that's not going to work. So who's right in this case? Should they have age verification? Like, I don't know, and I don't know how you make these things into laws. But your point, of course, is that everybody's just going to VPN around it, and the whole thing is pointless, is probably even more to the point.
A lot of people will upload their real driver's license or other ID, of course, and they'll be doing it to all manner of dodgy sites. And the probability of one of those sites being compromised and all the information being available to the highest bidder approaches 1, and that is not a good place to find yourself in.
Well, that about wraps it up for this week's Hackaday podcast. Thanks very much for listening. To follow the links, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, drop us a line, tips@hackaday.com. And until next week,
Eat, sleep, hack, repeat. I think I've lost you. Elliot, I've lost you.
hello.
Did that work? Whew. Right.
All germanium. Don't bother. I'm rambling.
There's nothing like a good rant about British politics, It's what Brits who live outside Britain do nowadays. Perfectly normal island.
Oh, damn it. That was clutch.
I'll stop recording now. Boom.